Yeah, so a rhombus fits all the descriptions of a parallelogram. So everything that we've talked about a parallelogram up until this point, it matches. Meaning your opposite angles are congruent, your opposite sides are congruent, your consecutive angles add up to 180. So everything that we've done so far works. It bisects, the diagonals bisect each other, etc. We've added two. So we've added the fact that they are perpendicular, and we've added the fact that they bisect the angles. So these two are new concepts here, that it is perpendicular and the angles are bisected by the diagonals. Example. So turn to page 432. Use rhombus QRST and the given information to find the value of each variable. So they have told us that it is a rhombus. Find y if the measure of angle 3 is y squared minus 31. What do we know about the diagonals of a rhombus? What did we just find out about them? They are perpendicular. Perpendicular means that angle 3 should be what measure? 90 degrees. So we should be able to say that 90 degrees equals y squared minus 31. And then we can add 31 to both sides. 121 equals y squared. So y is going to equal two possibilities. What are the possibilities?
11 or negative 11.
Positive and negative 11 are the options. That's all it wanted us to find was measure of y. All right. It now says find TQS if RST is 56. That's the next thing. So make sure you know what it's asking for. TQS is what they're wanting us to find if RST is 56. If RST is 56. All right, so what do we know about, if it's all the descriptions of a parallelogram, what do we know about RST and TQR?
They're the same.
They're congruent because this is a parallelogram, all right? This guy is 56, so that means this guy is also 56, right? Now we learned something new about a rhombus in particular. What do we know about this angle Q here? Because of that diagonal, what do we know? It's bisecting. So if they want just part of that, then what do we have to do to that 56? Divided by 2. So that's going to give us what? 28 degrees. Is both a rhombus and a rectangle then it is a square? All the properties of parallelograms and rectangles and rhombus can be applied to squares. All right, so squares fit all the characteristics. It is the most specific of the ones that we've talked about so far. And so if you look at this example, coordinate geometry, determine whether this parallelogram is a rhombus, a rectangle, or a square. List all that apply. All right, list all that apply. And so they want to know what this is. And you cannot just tell me it looks like this or that. Like, you need to give me information. And so this is where we start looking at what we need to prove. Distance formula is going to help me prove whether the sides are the same, right? Slope formula is going to help me prove if they are parallel or if they are perpendicular as well, right? If I did the diagonals, if the diagonals are perpendicular, then I know I have at least narrowed it down to a type of rhombus, right? And then if I can prove that not only are the diagonals perpendicular, but so are my sides, then I can probably prove that we have a square. All right, so the first thing they say is if the diagonals are perpendicular, we know we have at least a rhombus, if not a square. So we're going to start with diagonals, all right? Start with diagonals. All right, and if we want to prove perpendicular, how are we going to do that?
Find the slopes.
Find the slopes, all right? So if I want to find the slopes of my diagonals, I'm going to want to go from B to D and then from C to A, all right? So slope, that is my y2 minus y1 over x2 minus x1. So I'm going to say 1 minus negative 1 over negative 3 minus 3. This is from B to D.
Since I already graphed it out, can't you just do the thing where you count it?
I think it should, you'll get the same answer for sure. So we're going to get 2 over negative 6 or negative 1/3. negative 1/3. All right, and if we go from C to A, we're going to do the same thing. We're going to say negative 3 minus 3 over negative 1 minus 1. We will get negative 6 over negative 2, which will give us positive 3. We know they are perpendicular. We know they're perpendicular. Yeah. I know that I have at least the characteristic of a rhombus, right? If I prove that the diagonals then are also congruent, I have a characteristic of a rectangle. If I have a characteristic of a rhombus and a rectangle, I have a square, all right? And so I can take those same two and do the distance formula and see if they're the same length, all right? And so I can do the same exact ones. I can do BD and do the length of it, right? I already have my x2 minus x1 and my y2 minus y1, right? So I just have to square those. So x2 minus x1 is negative 6. Y2 minus y1 is 2. If I square those, I'm going to get 36 plus 4, square root of 40. Same thing for CA. You can probably see what's going to happen here. My x2's squared, x2 minus x1 squared, y2 minus y1 squared. Yes. The infield of a baseball diamond is a square, as shown at the right. Is the pitcher's mound located in the center? How would I know that? Yeah, so if it is in the center, it should be, bless you, it should be the diagonals was where they cross. And so if you can show that it's where the diagonals cross and they've told you it's a square, then it should be in the center. So yeah, if you look at a pitcher's mound, it falls on the diagonals. It falls where the diagonals cross. And so it will be in the center because according to a square, your diagonals bisect each other. And because it fits the rectangle, your diagonals are the same length. And so if this were just a rhombus, they would still bisect each other, but they wouldn't be the same length, and so it would not be in the center. But because it's a square, it is. For comparing them, a rhombus has all the properties of parallelogram. A square has all the properties of parallelogram. All sides are congruent. Diagonals are perpendicular. Diagonals bisect the angles of the rhombus. On a square, it has all the properties of the rectangle, all the properties of the rhombus. So what you really want to do is you want to have your parallelogram properties, what those are. You want to have the addition one, like what the rectangle brings to the table, what the rhombus brings to the table, and then the square fits all of those. All right? In rhombus ABCD, AB equals 2x plus 3 and BC equals 5x, find x. So if they gave us AB and BC, a rhombus has all four sides congruent, so you can just set those equal to each other and solve. You should have gotten 1. Find AD. Well, you can just plug it into any of these, and you would have gotten 5 for all the sides. Find the measure of AEB. Well, that takes no calculation at all because we know that they are perpendicular, so we know it's 90. Find the measure of BCD if ABC is 83.2. All right, so why do we know about parallelograms in general? Consecutive angles do what? Add up to 180. So you should have gotten 96.8 there. 96.8 there. Vertices. Determine whether parallelogram MNPQ is a rhombus, a rectangle, or a square. For this particular one, you would have gotten that it was a square because it fit a rectangle and a rhombus characteristics. So you would have gotten that this was a square. Diagonals as well. I mean, or you could do all four sides if you wanted to, but you wouldn't do diagonals. So if you cannot visualize where they are, sketch it. All right. So for this one, if I don't know exactly where it is on the graph, I'm going to just sketch it so I can see what I'm talking about when I do this particular one. And so M is 0, 3. N is negative 3, 0. This is kind of an easy one here, isn't it? P is 0, negative 3. And Q is 3, 0. And so if I wanted to do diagonals here, I mean, you can actually see the diagonals are perpendicular because they are actually on the axis, but that was nice of them. If I wanted to do diagonals, I could do the distance formula. I only actually need to do the distance formula when it's on an axis. If I want to go from N to Q, since both of my y's are the same value, I just subtract. Negative 3 minus 3 is negative 6, absolute value then. So from N to Q, I would get a length of 6. And then from M to P, I can just look at my y values there because my x's are the same. 3 minus a negative 3. M to P is also 6, right? And then perpendicular, I can just do my slopes. So my slope, you're actually going to get 0 and you're going to get undefined for this particular one. But M to P, you're going to get undefined because you're going to get a 0 on the bottom when you subtract those, right? And then N to Q, you're going to get 0 slope because it is a 0 in the numerator. So that's technically negative reciprocals because it's 0 on the top, 0 on the bottom.